Recently I tore apart an old voltmeter like this one over here, except a very cheap version. And one of the pieces I got out of it was the LCD screen, and there's something interesting about it that makes it worth taking a closer look at, and maybe there's one piece of it that is worth keeping for your spare parts box. Okay, let's do that close up. The upper piece is nothing more than an ordinary LCD screen, but underneath it is this backlit panel. Let me turn it on. And it requires 2.7 or 2.8 volts roughly to operate. And if we turn out the lights, you can see it produces a very nice blue glow, relatively even. And yeah, you could use this for a lot of different projects, whether you're a hobbyist, whether you're into model trains, or you need billboards, or if you just want to light up some display or something, a small item to display. This would be very nice. Now, what's interesting is maybe you can see over here, there's just a single LED operating it, and they've got this interesting piece of plastic. Let's do a super close-up and see if we can see what's going on underneath there to make it work. Let me point out one small feature before we continue, and that is normally an LCD screen has a reflective backing on it, and this one doesn't have it. In fact, what's going on here is this white sheet is acting as the reflective layer behind the LCD screen, and this panel has two sides to it. This one is translucent, and this one is absolutely white. So this is the side that goes against the LCD. It transmits light, but it also, under normal circumstances, will reflect light back through it. So the LCD will work normally because it has that reflective layer behind it. This acts as the reflective layer. And it will also, of course, act as a backlit screen. Okay, let's go on. If we look at the business end of this, we can see a K and an A, and this is where the wire is going, of course. And I'm assuming that means cathode and anode, and that's where the LED is. So let's peel off the layer and see underneath what kind of plastic they're using. It looks like just normal acrylic from this end, but I think they must have done something special to it to get it to transmit light all the way down along there. I've removed the LED itself. You can see that it's just a LED on a tiny bit of circuit board right there, and underneath is a piece of reflective material, I guess to capture as much light as possible and send it into the acrylic. Okay, so let's get that out of the way and take a closer look at what's going on with the plastic. Here we can see where I have peeled off both layers of the white reflective material that's still over here onto this side, and you can see that it's just covered with a series of bumps. Both sides of the plastic are, and I guess that's to allow light to reflect back and forth between the two white surfaces, one on this side, one on the opposite side, so that light can travel from the LED here all the way along here. So this is acting like a, I don't know, whatever you'd call it, a waveguide or something to move the light along to the other end. Okay, well, that's pretty much it for this backlit panel. Kind of an interesting way to do it, very low cost, very simple to use. Hope you find this useful and interesting in your home DIY projects.